in this scenario, two men are trying to move a box but can't. But can't move a box, so that means that the velocity is at 0 meters per second. The man on the left, 65 kilograms, so we're going to call him the left man, pushes with 150 newtons. So pushes right here at 150 newtons, and the man on the right, 55 kilograms, pulls with 60 newtons. So this is pulling. It'll be tension force. Pulling. Actually, we're going to draw it in a different place. We're going to say from here to here is the tension force. The rope is part of the box, and it's pulling with 60 newtons. The mass of the box is 60 kilograms and is located at a position of 20 meters. So we have 0, we're going to seconds, meters per second. Okay, 1, 2, 3, and 4. Since it's not moving, it is happening at 0 meters per second. So at 1, 2, 3, and 4, it's happening right here at 0 meters per second. And then here, at time, and this is meters, 0, 1, 2, 3, and 4, staying at 20 meters. So we can go 10, 20, 30, 40, 50, 1, 2, 3, 4, and for 4 seconds it is staying at 20 meters. Alright, and then the same thing here. We're staying at 20 meters, so t is equal to 0, 1, 2, 3, and 4, staying at 20 meters. Okay, and so we'll draw our interaction diagram. And the left man has an interaction with the floor as a normal force and a friction force. The box has an interaction with the floor and normal force and also a friction force. The person also has a normal force and a friction force. And each of them have gravity. Okay. So the man on the left has an interaction with the earth, with friction, normal, and so then that's 4 interactions. Okay, and we know that it's balanced because they're not moving. So we have the left man has an interaction with the earth in downward direction. Let's make that L a little better. So force of gravity on the left man with the earth happening at 65 kilograms, so 650 newtons. Okay, and we also know that the floor is pushing him up and he's pushing the floor down, happening also at 650 newtons. Now, here's the part where, okay, so the man is pushing the box in this direction, and the box is pushing the man in this direction. So we're going to have him go to the left. Let's see how far it is. He's pushing with 150 newtons. Okay, so I don't know why he keeps doing that. I'm so sorry. So it's a force that is normal on the left man with the box at 150 newtons. And so then that means that the force of friction on the left man by the floor is also happening at 150 newtons. Okay, so now the box let's see, how much does the box weigh? The box weighs 60 kilograms. So we have the force of gravity on the box with the Earth happening at 650 newtons. And then we have the force of normal on the box with the floor also happening at 650 newtons. The man on the left is pushing the box in this direction. So normal force on the box with the man on the left is happening at 150 newtons, but it's also being pulled by the right man at 60 newtons. So the man on the right is pulling the box at 60 newtons. Together, the force of friction on the box with the floor is happening at 150 plus 60, which is 210 newtons, and it's a balanced force. And we'll do Newton's third law pairs after we're done with all of them, with all the force diagrams. So we have the right man who weighs 55 kilograms, I believe. Let's double check. Yes, 55 kilograms. So force of gravity on the right man with the Earth happening at 550 newtons. And we have a normal force on the right man with the floor happening also at 550 newtons. And this has to be the same. And the right man is pulling to the right, so that means that the box is pulling him to the left. So it's the tension force on the right man with the box happening at 60 newtons. And the force of friction on the floor with the right box is happening also at 60 newtons. Now our third law pairs are going to be the ones that have the same force type and same feeler-dealers in different directions. So we have one right here, force of tension with the right man in the box to the left, and this one is to the right. There's our first Newton's third law pair. And our second one is going to happen with the box on the left man. And that's happening. Alright, now, weight of the box means force of gravity. Okay, so here's the box. It has a force of gravity with the Earth that is 650 newtons. And the Earth is being pulled up by the box also at 650 newtons. All right, and so then that is the end for scenario number 4.